Hello, this is Professor Simpson here with your Chapter 6 videos, in particular here 6.1 formula masses. You can see I have the learning objective there for you, calculate formula masses for covalent and ionic compounds. Now that term may sound familiar to you because we were actually given formula masses earlier this year when we introduced the, the concept of the mole. You may recall that we did some conversions between grams and moles, and the conversion factor was 1 mole equals the formula mass of a particular compound. This is a very important concept for us, and one that at this point in time, now we're going to quickly learn how to calculate that value. And moving forward, this will be something that you will need to do and on your own, and it will not be given to you like it was earlier in the year. Now, the formula mass is the sum of the atomic masses for all of the atoms in a substance's formula. Earlier this year, we calculated this value, or we saw how this value was calculated, this average atomic mass value, which, as you remember, is a weighted average of all of the naturally occurring isotopes for a particular atom. One distinction here between these two terms, formula mass and molecular mass, while they are the same, they are also slightly different. We use the term formula mass when talking about ionic compounds, and the term molecular mass when referring to covalent compounds, or those compounds where the atoms are bonded covalently. The process of calculating those values is the same, just you'll see that distinction in the nomenclature as you move along. So here's our first example, and it is a molecule. So this is the molecular mass that we're calculating here. This molecule, chloroform, has the formula CHCl3, and you can see how the breakdown here in this table: 1 carbon atom, 1 hydrogen atom, and 3 chlorine atoms. Then we take the average atomic mass from the periodic table of those 3 atoms, and you can see that in the case of the chlorine, we need to multiply it by 3 because there are 3 chlorine atoms. When we get here, we sum those subtotals, and we arrive at the molecular mass for chloroform, 119.37. Now, you may remember that ionic compounds are the result of ions bonding together and producing a neutral compound. In this case, we have the example I'm using here is aluminum ion with a 3+ charge and a sulfate ion with a 2- charge. And in order to get the ratios of those 2 ions, we use the crisscross method, and we would get Al2SO4 3 like this, and that is our neutral ionic compound. I just point this one out here because we just need to make sure, it's a pretty simple calculation, but we need to make sure we are aware of what these values in a compound tell us about how many atoms we have here present. So this 2 tells me I have 2 aluminum atoms. The 3 here tells me I have 3 sulfurs, and 3 times 4, 12 oxygen atoms. So again, if I take a quick look at this table, I will see the 2 aluminum atoms times the average atomic mass of aluminum from the periodic table, and so forth, to determine those subtotals, and then sum those subtotals to get the, and just to be consistent here with my point earlier, the formula mass of 342.14. That's all we have for this first section. That was a quick one, but as I said at the top, this will be an important first step in many calculations you will do throughout the year, especially when we are doing mole conversions in stoichiometry. So Now that we have covered it, it will no longer be given to you in the problems like it was earlier in the year. You will be responsible for being able to quickly and efficiently do this calculation.